Hello, this is a radians question where you have this shape here. It's made by this sector, this right angle triangle, and this other triangle that is nothing in particular. The points A, B, and C are in this line. We know this length, the radius of the sector, and we have to find in centimeters squared the area of the sector BDE, so this area here. The area of the sector, when we are working in radians, remember is 1/2 r squared, and the angle in radians. So we have everything is going to be 1/2. Radius is 5, so 5 squared, and theta in radians is 1.4. So this is 17.5. They say in centimeters squared. Yeah. So this is the first one. Then B says find the size of the angle DBC given your answer to radians to 3 decimal places. DBC is this angle here. DBC is this angle. This angle here. Let's call it alpha, for example. We don't know this angle, which means we cannot use 180 or pi radians minus this and minus this. So what we can think is in this triangle. In this triangle, we know the three sides and we need one angle, which means we can use the cosine rule. Cosine rule is going to be that this side square, so the opposite to the angle that we are looking for, is going to be the other 2 squared. So the opposite to the angle, 6.1 squared, is going to be the other 2 squared, 5 squared, plus 7.5 squared, minus double these 2, so 2 times 5 times 7.5, times the cos of the angle that we are looking for. Yeah. So we just make this with the calculator, and cos alpha is going to be 0.5872 something. Remember to check that your calculator is in radians just in case, and you do cos minus 1 to find alpha. So alpha, when you do cos minus 1, is 0.943 radians to 3 decimal places. Yeah, they ask to run to 3 decimal places. So this is the second part, just using the cosine rule. And if we need this angle, I'm going to do the opposite square equals and the formula. Then C, find in centimeters squared the area of the whole shape, giving the answer to 3 significant figures. So we have found like this area here. We have found the area of the sector. Yeah, and this was, let's call it A1. We need to find the area of the 2 other rectangles. This rectangle here, we know one angle, and we can use the formula of the area because we are able to find this height. Yeah, so it will be base times height divided by 2. And to find the height, we can use 5 sine alpha. Yeah, because sine alpha is the opposite, which is what I need, divided by the hypotenuse, which is 5. So this side here that I don't know, the height of the triangle is going to be 5 hypotenuse sine alpha. And I know alpha because I just found it. Yeah, so we are going to use that. Base times height divided by 2 for the area of that triangle. And I'm going to do it here. So A2 is going to be 1/2 times 7.5, which is the base, 7.5, times the height, which is 5 sine alpha, and alpha was 0.943 radians. Yeah, we do this with the calculator. Sine, again, check that the calculator is in radians and you haven't changed it. This is 15.177 centimeters squared. So this is A2. And then A3, let's call it A3 to the last area that we have here. So A2 was this triangle. Let's going to call A3 to this one. I have a right angle triangle. So the area will be this side times this side divided by 2, but I don't know either of the sides. What I can easily find is this angle here. because I know the total angle is 180 degrees, which is pi radians, and I know this angle and this angle. So the first thing I'm going to do is to find this angle here. And that angle here, let's call it beta, for example. If we try to find beta, it's going to be pi minus 1.4 and minus the other angle. So I found this area, I found this one. Beta is going to be pi radians minus 1.4 minus 0.943, and this is 0.9 to 3 decimal places, for example. They ask us to round to that, so let's keep that, radians. So that's the angle. And so A3 is going to be, we can find first the two sides or just use them straight away in the formula. So let's find it first. So AB is the adjacent. So if you just check this triangle, AB is the adjacent. So it's going to be cos, and this is the hypotenuse. So cos beta is going to be the adjacent divided by the hypotenuse, which means the adjacent, so this side, is going to be 5 hypotenuse cos beta. And we can do the same with this one. It's the opposite to the angle, so sine of this angle is going to be this side divided by 5, which means that this side is going to be 5 sine beta. Yeah, so we know both sides and we know beta, so we are going to multiply that in the area. So the area here, so this was beta, the area is going to be 1/2 base, which is 5 cos beta. So base 5 cos beta, and beta is 0.799 times height, and height is 5 sine beta. So times 5 sine beta, all in radians, and this is going to be 6.2478 centimeters squared. So the total area is going to be the three areas that I have. Is going to be the A1 that was 17.5, so 17.5 plus A2 15.177, and the last one 6.2478. And please remember to round at the end, so keep those values in the calculator and round the answer to 3 significant figures. So we find this number, and when we round, well, I can give you the actual number. So this is 38.9248, and when we round to 3 significant places, is going to be 38.9. Yep, and that's all. That's the question.